So, first, we have, here's your little degree bubbles. We're going to fill out the degrees all the way around. So there's our 0 degrees. And up here we have our 90 degrees. And so if that's 0 and that's 90, what's this one that's exactly halfway in between? 45. Woo! We'll do better. We'll do better. 45 is exactly halfway in between. And then if you ignore this halfway in between mark, this is 1/3 and another third and another third. These are all thirds here. So how many degrees if you took 90 and divided it into 3 pieces? 30. So this is 30 right here and 60 right there. All right. This was 90, and then Roderick, what's this one? 180. Perfect. And we know that if we ignore this one in the middle, that these are 30 degrees apart. So if that's 90 and we go 30 degrees, what's this one? 120. And if we go 30 degrees more to get this one, what's this one? 150. And we know that the middle one is 45 degrees from this, and it's 45 degrees from that. So if we take 90 and we go 45 degrees, then what should this one be? 135. Good. All right, this one is 30 degrees more, so what should it be? 210. This one is 30 degrees more than 210. 240. And then we already know this one down here, 270. Which one should be between 210 and 240? 225, good. 225. Yep, 270 is down here. And then we go 30 degrees more, 300. And we go 30 degrees more, 330. And we go 30 degrees more, 360. There's our complete circle. And then what's halfway in between? 315. Okay. So with our first color, we're going to do the axes, the x-axis, the y-axis, like we normally have. So we already know what these are in radians. We say that this is 0 pi, and the top half of the circle is a whole pi, so we put 1 pi over here. And if this is 0 pi and this is 1 pi, then what's halfway between?
Half pi.
Half of a pi, and we write that as pi over 2, and we read that out loud as pi halves. So we had 0 pi, we had 1/2, we had 1, and then what's down here?
1.5.
1.5, it's 1.5. How do we write that as a fraction? 3 halves, yeah, which is 3 pi over 2. So 3 pi over 2. So we have 0, 1/2, 1, 3 halves, and then this would be 4 halves. What's 4 halves?
2 pi.
2 pi. Okay, take another color. All right, so if this is 1/2, and my blue is halfway on the way to 1/2, then what fraction is that? 1/4. So we have pi fourths, and I want you guys to watch how I do my fractions. Are you ready? This is the pattern. We have 1/4, 2/4. What's another way of saying 2/4? Half. 3/4. Can I simplify that? No. So since I can't simplify it, I write it down. 3/4. This is 4/4. What's the simplified version of 4/4? 1. 5/4. Can I simplify it? 5/4? No, so I write it down. This is 6/4. What's the simplified version of 6/4? 3/2. 7/4. Can't simplify, so I write it down. And then 8/4, which is 2. Okay. All right, and then last one. The last one is all of the rest. Now, when you count, did you notice that even when we were doing the blue ones, we still counted the pink ones, even though we'd already written them? The same thing is going to happen with the green ones. So while I'm doing the green ones, I'm still going to count the pink ones. They're still part of it. So what we want to do is we want to see how many sections there are in 1 pi. So 1 pi is the top half. I've got one section right here. I have another section right there. I have a third section right here. A fourth section right here. A fifth section right here. And a sixth section right there. So what's my fraction?
6 sections.
I've got 6 sections, so I'm going to go by sixths. Okay? You guys ready? All right, so this is 1/6. Can you simplify that? No, so you write it. This is 2/6. 1/3, good. So we're going to write pi thirds. This is 3/6. Does that match what we already wrote? 3/6? Yep. This is 4/6. 2/3. This is 5/6. Can we simplify that? No. So this is 5/6. This is 6/6. Does that match what we wrote?
Yes.
Yes. This is 7/6. We got to write it. 7/6. This is 8/6. 4/3. Good. This is 9/6. That matches. 3/2. This is 10/6.
5/3.
5/3. This is 11/6. You can't simplify, so you write it. And then this is 12/6.
2.
2. Okay.
11/6.
Yep. All right. Do you guys see how it works? Okay. So when we do the degrees, we can kind of think through those. When we do the radians, we got to know fractions. We got to do some fraction work. Okay. Flip your unit circle onto the back side. Now, the unit circle is a big idea. If you missed any blanks, don't stress. Google unit circle, and you'll have approximately 500 images to look at that are all correct, because this is a very common idea. Okay. On the back, we're going to write rationalizing.
Is it notes?
It's kind of notes. It's very brief. Denominators. Rationalizing denominators. Okay, so here is how rationalizing denominators works. If you have a problem like 5 over the square root of 5, they say, nope, that's not proper. You can't leave a square root on the bottom of a fraction. Have any of you guys seen that before? No square roots on the bottom of a fraction. So we're going to multiply this by square root 5 over square root 5.
Why can't you have a square root at the bottom of the fraction?
Just because it's not proper. Somebody decided it's not proper, and we've been like, oh yeah, I believe that. And so forever after, we just don't do it. Okay, so the way to get rid of the square root, and you'll see in a second why it works, is to multiply. If I have the square root 5 on the bottom, then I'm going to multiply by square root 5 on the top and the bottom. So on the top, we just go straight across, and the top is going to be called 5 square root 5. On the bottom, if you do square root 5 times square root 5, what do you get? You get 5, right? So there's two ways to think of that. You can think of that as the square roots cancel out, you just get 5. Or you can say square root 5 times square root 5 would be square root of 25. And what's the square root of 25? 5. Okay, so two different ways to think of it. When you guys look at this fraction, what do you see?
Something weird.
You can cross out the 5.
Yeah, this times 5 and this divide by 5 cancel, and your final answer is just 5. So the fraction in the beginning and this end answer look a little bit different, but if you type them out on your calculator, you'll notice they actually are the same decimal. So 5 divided by square root 5 is the decimal 2.236. Square root 5 is also 2.236. They're actually the exact same number. Okay, they just look different. This one is not proper, so we don't usually use it. This one is proper, so we'll use it instead. Okay. Let's say we had 1 over the square root of 7. How would we fix that?
Multiply both sides by square root.
Yeah, square root 7 on the top, square root 7 on the bottom. So what does that leave us on the top?
7.
What?
Oh, no.
1 square root.
1 square root.
1 square root 7. What does that leave us on the bottom?
7.
7. Does anything cancel out this time?
No.
What if we had 2 over square root 6? How would we fix this one? Multiply by square root 6 on the top, multiply by square root 6 on the bottom. What are we going to get on the top? 2 square root 6. What are we going to get on the bottom? Just 6. Yeah, and that 2 over 6 can be simplified to be 1 over 3. So I'm going to take the 2 and divide by 2 and get 1. Take the 6 and divide by 2 and get 3. And so I would say that my final answer in the proper form is square root 6 divided by 3. How are we doing with that?
So if you always have, like, for example, if you have like 6 over square root 6, you know that your final answer is going to be square root 6 without doing the math.
Yeah, there's some patterns to these, so there's a few different combinations, but once you do a bunch of them, you'll stop showing your work because you'll already know what it's going to look like. Yeah. What if I had square root 7 over 2? What do I have to do?
Times by nothing.
Nothing.
Oh, because the square root's at the top.
Square root's on the top. That one's good.
That's my little lazy.
What if I had 1 over square root 3?
Times by 3.
Times by
Square root.
square root 3 over square root 3. And what would we get?
1 square root 3.
Philip, I'm about to come over there. You can use that marker stick to smack you upside the head. Whoa. Took it too far. Took it too far. I'm sending that to your mom. All right, what do we have? We got square root of 3 on top. What do we have on the bottom? 3. All right.
You put a 1 in front of 3.
I could put a 1 in front of the 3. Did it matter if I didn't have it?
You did it for
Yeah, I did it up here, but not down here, because technically, if I have square root of 7, that's like saying I've got one of them. If I say 1 square root of 7, I'm just pointing out that I only have 1. Yeah, same thing. All right. Back in the day, in middle school, you would have learned about special right triangles. Nowadays, you might not have learned it. Depends on your teacher. Roderick, sit down. So here we have a special right triangle. This is a 45, 45, 90. So what that means, if the two angles are the same, it means the sides that correspond to them are the same. So we're going to call this a length of A and call that a length of A. Those would be exactly the same. And if we did the Pythagorean theorem on this, we would find out that the hypotenuse is A square root 2. And we don't have time to go over why that works today, but if you wanted to, I could show you guys in the future at some point. No big deal. All right, so what we have right here, actually, let me show you the other one too. This is a 30, 60, 90 triangle, so we're saying that this right here is 30 degrees. This right here is 60 degrees. And if that's the case, then the smallest side would correspond to the 30-degree angle. It would be right across from it, and that would be a length of A. The hypotenuse would be double that. It would be a length of 2A. And the third side would be a length of A square root 3. So it used to be in middle school, they would give you a bunch of these triangles, and they'd be like, oh, this side is 5. So what are the other sides? And you would have been like, oh, that side is also 5. And that side is 5 square root 2. You just plug it in for all the A's. Or over here, they might have said this was a side of 5, and so then you would have said that's a side of 10, and that's a side of 5 square root 3. So this is something that kids used to learn a lot. All right, so what we want to do is we need to figure out what the side lengths are so that we can fill in the rest of our numbers on the unit circle. So on the unit circle, they say this is a point that's on the edge of the circle, and they want to know an x and a y coordinate for that edge of the circle. That's what the unit circle is saying. And since it's a unit circle, it has an automatic radius of 1. That's what it means by unit, 1 unit. So it always has a length of 1 from the middle of the circle to the edge of the circle. And so for us, we're going to build a right triangle by taking a line and dropping it straight down to the x-axis, like this. So we have a triangle right here. And if you look at your triangle, this bottom side is going to be the same as the x-coordinate of that point. Do you guys see that? The bottom side would be the x-coordinate of the point. It's how far to the right you go to get to the point. And then this side right here would be the y-coordinate of the point because it's how far up you go to get to the point. You don't really need a marker. I mean, you can use them if you want, but you don't need them. Okay. In the unit circle, this angle right here is a measurement of 30. That angle is a measurement of 30. And so that means that this angle up here would be a measurement of what if this is a right angle? 60, right? Okay. So if we compare this triangle with this triangle right here, then the 1 is the same as what side?
2A.
The 2A side. So we're going to write the equation 1 equals 2A. And what we want to do to be able to find the lengths of the other two sides is we want to know what A represents. Because if we know what A represents, we can plug it in here, and that will tell us our Y value. And we can plug it in here, and that will tell us our X value. And then we'll have X and Y, and we'll be done. Right? So how do I solve for A? Divide by 2. So A equals 1/2. So if A equals 1/2, then what should I say that my Y coordinate would be? 1/2. So this point up here is going to have a Y coordinate of 1/2. What should I say my X coordinate is?
1/2 square root of 3.
Yeah, it's going to be 1/2 times the square root of 3. And how do I multiply those two things together?
Put it over the 30.
Put this over 1, right?
Yeah.
And then we multiply the tops together. So what's the top?
Square root of 3.
Square root of 3. We multiply the bottoms together.
2.
2. So the X is square root of 3 over 2. Okay, so on our unit circle, we look at where it says 30-degree angle, and we know that the X coordinate is square root 3 over 2, and the Y coordinate is 1 over 2.
That's a lot of work.
That was a lot of work.
Yes, we could. Like, for them.
Square root 3 over 2 for the X value, 1 over 2 for the Y value.
This is because we figured out the 30, 60, 90.
And this is because we use the 30, 60, 90 to help us figure out the numbers. Now, if we keep looking at this, those numbers can actually help us figure out other spots on the unit circle. So do you guys see how these 2 points are kind of similar? They're just on either side. So if this one goes to the right, root 3 over 2, and up 1/2, what does this one do? Does it go to the right and up? It goes to the left, root 3 over 2, and up 1/2. So if you go to the left, root 3 over 2, what did you do? Negative, yeah. So we're going to say left, root 3 over 2, and up 1/2.
That's a negative?
Yep, because you went to the left. So negative root 3 over 2, up 1/2. And then this one corresponds to this point right here. So here we went to the left, root 3 over 2, and up 1/2. For this one down here, we're going to go left, root 3 over 2, and down 1/2. So negative root 3 over 2, and down 1/2. And then down 1/2.
And I get this at all.
We're going to do it 3 times, so hopefully by the time we do it, then you'll see it more. All right. Now, do you guys see how the original point we did, do you see how it corresponds with this one? It's in the same spot, just on the other side. So this one went to the right, root 3 over 2, and up 1/2. This one is going to go to the right, root 3 over 2, and down 1/2. So right root 3 over 2 would be positive. Down 1/2 would be negative. Now, remember what I said before we started. I'm not going to make you go through this process again. I'm going to tell you where the numbers come from so they make sense. Okay?
Where did they come from?
That's what I just showed you, the triangles.
We gotta wait.
All right. Okay, here is our next triangle. So we are looking for points on the edge of the circle that have an x and a y coordinate. The radius of the circle is still 1. It's still a unit circle. And so the triangle, if we drop a line straight down, there's the triangle. And this right here is a 60-degree angle. So then what's this right here? 30. And our x value is down here because x always goes to the right and left. And then we've got y, which goes up and down. So do you see how the x is the little side this time? And we still have a 30, 60, 90 triangle. It's just flipped on its side this time. It doesn't look the same as the other one, but it's still going to have all the same measurements. So the little side here is an x. What was the little side on this one? The little side? Y. It was y. So the little side here was 1/2. So what's the little side down here? 1/2. On this one, the medium side, because the longest side is 1, the longest side is the hypotenuse. Over here, the longest side is the hypotenuse, it's 1. It's the same triangle, it's just flipped on its side. So this one has a medium side of root 3 over 2, so what's this one going to have a medium side of?
3 over 2.
Root 3 over 2. So the x-coordinate is 1/2. And the y-coordinate is root 3 over 2. So the x-coordinate is 1/2. The y-coordinate is root 3 over 2. So we're going to fill that out on our unit circle. We have our x-coordinate is 1/2. Our y-coordinate is root 3 over 2. So that means that to get to this point, if you start at the center, you go right 1/2, up root 3 over 2. So right 1/2, up root 3 over 2. To get to this point right here, what would you do?
Negative 1/2.
Yep, left 1/2, so that's negative 1/2, and then
Right 3 over 2.
up root 3 over 2. So left 1/2, up root 3 over 2. So the x-coordinate is negative 1/2, and the y-coordinate is up root 3 over 2. So negative 1/2, positive root 3 over 2.
So they're just like the green lines are the same split.
Yeah, the green lines have like all the same numbers. Yeah, they just changed. All right, now look at this one. So this one was left 1/2 up root 3 over 2. This one's going to be left 1/2 down root 3 over 2, so they're both negative. So we got left 1/2 down root 3 over 2. So negative 1/2 negative root 3 over 2.
Same for this side too.
How about this one? What's this one going to be?
Down 1/2.
Wait.
Negative 1/2.
It's going to be right 1/2 this time. Right 1/2, so it's positive 1/2.
And then negative.
And then down root 3 over 2, so negative root 3 over 2. So right 1/2, down root 3 over 2. All right. Take your notes and flip them over. We got one last one. Okay. So on this one, our radius is still 1. We're still looking for a point on the edge of the circle that's got an x-coordinate and a y-coordinate. We're still drawing a triangle by dropping a line straight down. The bottom side of the triangle is still an x. This side of the triangle is still a y. And this time our angle here is 45 degrees. And so that means our angle up here is also 45 degrees. So I went ahead and wrote down, you don't need to write this because you have it on the front of your paper, but I went ahead and wrote down what the special right triangle was that we're referencing. It's that 45, 45, 90. And we know that these two sides are going to be the same. So in our triangle over here, we know that the x and the y coordinate are actually going to be the same on this one. And we know that the hypotenuse is a square root 2. So in this triangle, our hypotenuse is 1. So what should I do to figure out what the a equals?
1 equals a square root 2.
So 1 equals a square root 2. How do I get a all by itself? Divide by square root 2. So that means that 1 over square root 2 is what the a equals. And is that a proper answer for a? No. So how do we fix it? Multiply by square root 2 over square root 2. And so on the top, that's square root 2, and on the bottom, that is 2. Yep. So we're going to say instead a equals square root 2 over 2. So that means that your x and your y are just the plain old a side. So that means that x equals square root 2 over 2, and y equals square root 2 over 2. The x and the y coordinate are exactly the same. Okay, so we bring our unit circle over.
Oh my God.
So what's this point right here? Root 2 over 2. Root 2 over 2. This one goes to the left root 2 over 2 and up root 2 over 2. So the first one's negative. The second one is positive. Then for this one, we go left root 2 over 2 and down root 2 over 2, so they're both negative. Mm-hmm. And remember, if you miss one, what can you do?
Go online.
Google unit circle. There's a ton of
It's
them.
500.
There's lots of them, probably more than 500.
500.
I thought actually that it'd be fun to get a unit circle tattoo on my cheek ring. But like mirror image, so that I could then, if I ever needed it, I could just look in the mirror. So it'd be like written backwards, so that when I look at it, you know what I'm saying? All right, this one over here should be what?
Square root 2 over 2.
So right.
Square root 2 over
Good. So the x coordinate should be positive because it went to the right. The y coordinate should be negative because it went down. Okay.
Why didn't you get a tattoo?
Just haven't committed yet. All right. We've got the pink ones left, right?
Yes.
So we have to think about these ones. Now this point is on the edge of the circle. This is a radius of the circle, so how long is this length? 1. It's a length of 1. So I went to the right 1, and I did not go up or down.
So just 1.
So it's 1 for the x coordinate, and what about the y coordinate? 0. Okay. For this one, I'm not going to go left or right. I am just going to go up 1.
So 0, 1.
So 0, 1. For this one, I'm going left a length of 1.
Negative 1.
So negative 1, 0. And for this last one, I am going down 1. 0, negative 1. Okay. All right. We have just a few more things on your notes. Oh my gosh, whiny, whiny. All right, go ahead and draw a circle off to the side. I'm being clever and just tracing the one I can see on the other side of the page.
Oh my God, please don't eat me. Please don't eat me. Please don't eat me. Please don't eat me. What is it? Okay. Don't eat me. Just don't eat me.
Okay, so you're drawing this. And I'm just marking it the same way that I marked all the other ones. So I'm marking, this is the point on the edge of my circle that has an x coordinate and a y coordinate. I'm showing my radius is 1. I'm showing that my angle is the one that's here at the origin, right? That's where 0, 0 is. That's where my angle is. I'm showing that this is a side length of x and that this is a side length of y. So, what is the name of the x side? Yeah, what's its name? Adjacent. What is the name of the y side? Opposite. What is the name of the one side? Hypotenuse. Okay. So, sine is opposite over hypotenuse.
Right.
All right? So, sine is y over 1. What is y divided by 1? Y. Okay. Cos is adjacent over hypotenuse.
So x over 1.
So it's x over 1. What is x divided by 1? X. So here is how we avoid using our calculator. Are you listening?
Yeah.
Here's how we avoid using our calculator. If I want to know what cos of a specific angle is, I just look at the x coordinate. If I want to know what sine of an angle is, I just look at the y coordinate. You guys see that? If I want to know cos, I look at x. If I want to know sine, I look at y. It only works as long as the angle is one of the ones that I can find on the unit circle. I have to be able to find it on the unit circle, but if I can find it on the unit circle, it means I do not need a calculator. Okay. All right, tan is opposite over adjacent. So what should I write for that? Y over x. Y corresponds with sine. So tan could also be described as sine divided by, what does x correspond to? Cosine. So people think of tan two ways. They think of it as y divided by x. They also think of it as sine divided by cosine. Those are things that are hard to remember when you get started, so we're going to add them to our unit circle so that we can always reference that. So on my unit circle, I'm going to write my x-coordinate is cos, my y-coordinate is sine. And then I'm also going to write that tan is y divided by x, which is the same thing as sine divided by cosine. Okay, so from now on, when you are looking at an angle, if you look at this angle and you recognize, and you'll get better at this because you'll get more familiar with it, if you look at that angle and you say, that angle is on the unit circle, then you do not get to use a calculator. So 240 is on the unit circle. I want you guys to find it. 240 is on the unit circle. I want you to find it. What quadrant is 240 in it? Yeah, it's in quadrant 3. So here's 240 right there. They want the sine value of 240. Is that the x-coordinate or the y-coordinate? For sine?
Y.
It's the y-coordinate. So here's 240. Sine of 240 is the y-coordinate. So what should my answer be? It should be negative root 3 over 2. So for sine of 240, we're going to write negative root 3 over 2. All right. Now you can check your answers on these. So I already got my answer without a calculator. I can make sure my calculator's in degrees, so make sure it's in degrees. I can type sine of 240 degrees and get a decimal. And then I can type negative root 3 over 2 and make sure it has the same decimal. And that's how I'll know if I got it right or not. So the reason that we are using the unit circle is because it allows us to get exact answers. The calculator can only do an approximate answer for this problem. Your unit circle can give you an exact answer for this problem. Okay? All right, let's look at the next one. Cos 135, what quadrant is 135 in? It's in quadrant 2. We want cos of 135. Do we want the x-coordinate or the y-coordinate? X-coordinate. So what should we write down? Negative square root 2 over 2. Okay. The next one says tangent of 45. Tangent of 45. So which quadrant is 45 degrees in? It's in quadrant 1. There's 45 degrees. How do we find tan?
Y over x.
Yeah, we do the y value divided by the x value. So if we are doing tangent and we are doing the y value divided by the x value, they wrote down on your paper they had root 2 over 2 divided by root 2 over 2. Do you agree with them? Is that right? Do you agree with them that the answer should be 1?
No. Yes.
How did they get 1?
It's the same thing.
It's the same thing divided by itself. Does that equal 1?
Yes.
Yeah, they did that right. Okay. I want you to take a moment and do sine of 300. See if you can figure out what it should be. Sine of 300. So on our unit circle, we look for 300. What quadrant is that in? Quadrant 4. And it's sine, so are you looking at the x-coordinate or the y-coordinate? X. The y-coordinate, good. Looking at the y-coordinate. And what do we get? So negative square root 3 over 2. All right, so here is your homework for tonight. Are you ready? I want this whole section done. So 1 through 15 right here, this whole section done. And then go ahead and flip it over. And then I want these 3 sections.
Whoa, you're right.
Actually, a lot of you guys don't have calculators, huh?
Yeah.
Okay, I lied. Just the 3rd section.
Oh, I'm sorry. Thank you.
So that's 1 through 10 on the bottom.
So just this one where it says find the exact value, what it means when it says the exact value is use your unit circle. All right.